Ladies and gentlemen, welcome back to Math 30-1, Chapter 4, Section 2, Combining Functions Algebraically, Part 2. Now, as I said before, you have equations. I expect you to graph them with a graphing calculator. I'm just too old and too lazy. Now, here we're moving on to the nasty one. Find the domain and range of h of x, which is f of x divided by g of x. And before I forget, that will also be written as f divided by g of x, like that. Now, let's see if I can screw this up again. Remember, when we're doing fractions like this, that the numerator, we're talking about zeros. We look at the numerator for zeros and x-intercepts. Chapter 2. And the denominator, we're looking for asymptotes. Holes, vertical, horizontal, or oblique. Yes. Oh yeah, and that of course means synthetic division. Alright. So, this f of x over g of x is the square root of x minus 2 divided by 2x plus 1. Now, right off the bat, domain, x is greater than or equal to 2. That's a restriction on the original function. That continues. Now, here, the other restriction, you got to think about it for a minute. G of x, or 2x plus 1, cannot equal 0. So, we have to solve for x here. Minus 1, minus 1. 2x cannot equal minus 1. Divided by 2. Divided by 2. X cannot equal minus 1/2. But that's okay, because x starts at 2 here. Alright, now I said domain. That's easy to solve. Range, oh dear, graph it. I'm not going to try to figure that out algebraically. Right? So I want you to graph it, and I think you'll find that y is greater than or equal to 0. I'm not going to bother drawing the graph, but I'm going to ask you to pause the recording and graph it and confirm my answers. All right? So pause the recording and check. All right, welcome back. Tell me I'm right, please, because it's embarrassing when I screw up. Now, another version of this question you might see would be this. F of x equals square root of x minus 2. G of x is 2x plus 1. Find the value of j of 3. Now, that's f of x, f of 3 plus g of 3. So, what I suggest you do is solve it for x equals 3. So it's the square root of 3 minus 2 plus 2 times 3 plus 1. Okay? So just plug in 3 and solve. This is the square root of 1 plus 6 plus 1. This is 1 plus 6 plus 1, which is 8. Okay. All right? So that's fairly straightforward. Now I will point out, we did solve for f of x plus g of x back here. So that's the equation right here. X plus square root of x plus 2 plus 2x plus 1. So you can graph that and plug in 3. Oh, we did solve that back here. It is 8. Woohoo! So, if you wanted to combine the equations and then plug the number in, you can do that. But I'm trying to be economical with our energy here. Now, if I want to be a bit of a poo head, notice the trick here. This is k of 6 equals f times 2g of 6. This is f of 6 times 2g of 6. So we have to figure out what f of 6 is and g of 6 is. Anyway, so this is, let me see, equals the square root of 6 minus 2. Okay. Multiplied by 2 times, let me see, 2 times 6 plus 1. Not difficult, but lots of little steps in there. Poopy. So, guess I got to do this. So, square root of 6 minus 2, that's the square root of 4, which is 2. Now, this is 2. 2 times 6 is 12 plus 1. That's 2 times 13. So 2 times 2 times 13. I think that's 52. So k is 6. It's 52. Okay? Difficult? No, but lots of steps. All right, a couple more examples. Now notice I'm changing the equations here. F of x equals square root of x plus 3, and g of x is bracket x minus 2 squared. I want you to find the domain of m of x, which is f of x over g of x. Too much work. I shouldn't say that, but it's something I expect you to be able to do. X plus 3 over x minus 2 squared. So, offhand, x plus 3 is greater than or equal to 0, so x is greater than or equal to minus 3. So my domain, x is greater than or equal to minus 3. Now, so far so good? Good, but we've missed something. Remember my denominator, x minus 2 squared can't equal 0. So I square root both sides. X minus 2 can't equal 0. X cannot equal plus 2. Oh, there's a trick in there. So x is greater than or equal to 3, but x cannot equal 2. Ooh, there's a zinger or a ringer in there. Now, this doesn't cancel out, which tells me it's a vertical asymptote. All right, now, oh, poopy, I said range. Ah, darn it. So we do have to graph this darn thing. So grab your graphing calculator and graph this. Actually, I apologize. No, I shouldn't apologize. That should have been the first thing you did. As I was explaining this, you should have paused the recording and graphed it. Now, when you do graph it, you get something like vertical asymptote, and range appears to be y is greater than 0. Greater than or greater than or equal to, it's hard to say. No, it would go down to here. So 1, 2, 3. This hits 0, so it's greater than or equal to 0. Now that's a little hard to see, and honestly, they don't always ask about the range on the diploma, but they always ask about the domain. Okay? Now this video is getting kind of long. I'm going to stop here. I want you to look at this carefully and look at the tricks, and then we're going to go on and do the last two examples, okay? Any questions, shoot me an email. Otherwise, good luck.